So water diseases are the real problem that people wanted to address. If our water just tasted bad and if it just looked kind of funny, but it didn't make us sick, then we probably wouldn't have spent so much money on it as we do now. In fact, there are places where the water does taste kind of bad, but it doesn't make people sick, so we just deal with it, right? We live with it. But we never just accept our water making us sick, okay? And so disinfection is key. We're going to talk about different things. Anyone know what this cool Star Wars ray gun is? Oh, I just gave it away. Star Wars ray gun. What, any idea? UV. This is a UV disinfection chamber. And sadly, I don't have a lot of lecture material on UV. But I do want to present it. This is something that is used. Has Dr. Friedman talked about disinfection at all? Yeah? So UV is actually used around this area. It's used more in wastewater treatment for disinfection. And we're going to talk about some reasons that might be advantageous too. Okay. So here's the history. Cholera. Oh, I'm sorry, typhoid. We're talking about cholera in a minute. Typhoid cases. Over time, some historians got together and they looked at the records and they saw that typhoid has been a problem from the 1890s up into 1907 or so, lots of typhoid. And then we started putting filters and boom, typhoid started decreasing. And then we put in chlorination and boom, typhoid cases go down and down. We get better and better at our chlorination methods. More and more people have chlorinated water, and typhoid has gone down tremendously. There are people in the world who say we should not be adding so many chemicals to our water. And I can understand why they feel that way, because just the idea of adding chemicals to our water is kind of a weird idea or scary idea. But the data show that our life has improved dramatically because we add this chlorine to our water.
Why is there a little peak when chlorination started?
Oh, I think that's just random scattering the data. But I don't really know. I think it's just random scattering. That's my guess. Good question. Well, maybe we'll have to look into that. I'd be more curious to know what are all these huge peaks, But okay, so a few points in the history. 1831 to 1854, cholera was endemic in England. So lots of people are dying from cholera. 10,000, upwards of 10,000 people. In 1854, they had this particular scenario, and I'm just going to jump to the map here, which is the next slide. This guy, John Snow, started paying attention to where the cholera epidemics were happening. Have you guys already talked about this guy in other classes? You have? Aww. Has anyone ever shown you this map? I doubt it, because it took me a while to find it. You said yes, Michelle? They showed you the map already? Who was that?
It was at Tri-County.
Oh, at Tri-County. Oh, so we're up to snuff with Tri-County finding. All right, so here's his map. I know you can't read it, but when you look at the slides on your own, you can kind of zoom in and read these things. This is Broad Street right here. So John Snow, he was putting together this map of the cholera cases, and this is a little bar chart. It's a cool map, actually. I wish some of my research had this cool map and bar chart combination. But the long bars is where you had a lot of cholera cases, and he said, oh, here's the pump right here on Broad Street. Here's another pump over here, not so many cases. Here's another pump, not so many cases. And he put it together and said, I think Broad Street. The Broad Street pump is where we're getting our cholera from. People didn't know that. They didn't know that it came from water. And so some people didn't really believe him. But he interviewed people, and he looked at some of the cholera cases that were further away, and he said, where do you get your water? You have a pump right here, right? And they said, well, I don't like the taste of this pump, so I go to the Broad Street pump. And then they got sick. So he's like, okay, that's it. He encourages them to remove the handle from the pump, and the cases drop. There's actually some debate about whether the cases were already going down. Was it correlation or causation or just simple correlation? But nevertheless, it's a key piece of history. We also have Koch discovering cholera and growing the organism. Louis Pasteur publishes about human infections and pasteurization. And when we look at disinfection and water treatment, there's some other history. In Hamilton, Ontario, people were dying, and they decided to connect they connected the wells to the cholera, and they installed a pumping station and a reservoir built to send it through beach sand. So we're talking a little bit about filtration too here. That was a disinfection method back then. The cholera epidemic was halted, and that's a first success for environmental engineers before there were environmental engineers, I guess. They didn't call themselves environmental engineers, but that's essentially what they were doing. Who are the people we care about, or what are the organisms we care about? Bacteria, these are the big guys that mostly we deal with. Lately though, viruses are problematic, and protozoa are also problematic, especially crypto and giardia. We just call it crypto for short, cryptosporidium. Has anyone told you about the Milwaukee crypto outbreak?
Friedman did.
Friedman did? I'm gonna have to talk about wastewater and steal some of his stories. But well, I'll tell you a story that you probably haven't heard unless I told it in this class already. But there's a guy, and I think he teaches in the public health. He's a lecturer in public health, and we were in a meeting together and we were just chatting about what we did and courses we taught. And I talked about disinfection, and he said, "Oh, I actually lived in the suburbs of Milwaukee during that cryptosporidium outbreak." And he was like in high school, and he was on the track team. And when that outbreak hit, like lots of people got sick. Tons of people got sick. And in fact, they had a track meet in Milwaukee, like one of the weekends that was a serious weekend of the crypto outbreak. And their team did not drink the same water as Milwaukee's, so their track team was all healthy. But all the other schools that drank the Milwaukee water had cryptosporidiosis, and like half the track team or several key members of the track teams were out sick, so they won the track meet. And they weren't a very good school usually, but they won that year because of cryptosporidium. And I think that helps us see the widespread nature of it. Like when you look at the numbers, it was something like 50 deaths, I think. And 50 deaths is pretty huge, I guess, for outbreak. But the number of people affected by it were many, many more. And so cryptosporidium, that's one case where we needed advanced treatment. And I'll tell you sort of the key to that story is that they were using chlorine, but it got cold, and chlorine doesn't do as good a job against cryptosporidium in the cold. So after a lot of research, that sparked a ton of research in environmental engineering on cryptosporidium, and we learned that if we use ozone instead, it can kill crypto even at the colder temperatures. So now Milwaukee uses ozone, and a lot of places around Milwaukee and the Midwest where it gets cold, they switched over to ozone for cryptosporidium specifically. Okay, 11 o'clock. Thank you guys for attending and behaving. And I will see you next Friday if you choose.